So I suggest that maybe we'll start with just a round table in the sense that if you have any comments on other people or what you want to say. Okay, so let's start with if you have a comment on your presentation or on others' presentation or questions to the panel.
Yeah, well, I just finished, so not really.
Okay.
Yeah, I don't know. It's maybe a question for the audience. So, when developing some open source or free hardware, do you have some feedback from those people doing some deployment, some mass deployment? Do you have some feedback? Or said differently, how do you define your roadmap?
Depends who you are.
Just to see if there is a channel of communication, or if it is, industry and mass production and academia, or which are completely disconnected. I'd like to understand how things work. If it is like producer to consumer, kind of, or if we need this kind of event is useful to create some ties. You see.
So I've been working with open source silicon for 10 years now, and has been partly outside of my work as a hobby, and it's been partly within my work. So I'm using increasingly more open source silicon in my commercial projects over time, and this is what I've been envisioning for a long time. That will come to this, but there are just still some pain points, and I think the overall infrastructure is the biggest thing holding us back now. So we're talking about deployment. We can either talk about FPGA or ASIC, and I deal mostly with FPGA, and in those cases, the things that are limiting us is availability of some certain IP cores, and also simulation tools, I would say.
Yes, there was a 0 Point has not really considered going open source, but I'm still quite interested to see, I mean, what would be good models, business models in open source. And I think that would be an interesting discussion.
From my perspective, what I'm finding interesting in watching this transition try to occur for a number of years, and comparing it to when Linux first was showing up, and the hue and cry that, oh my gosh, the computing industry will come to an end by the commercial vendors of operating systems. I mean, with the advent of open source software. Clearly, the future for those folks from a business model standpoint was somewhat unknown. And that unknown state of mind can be scary. As engineers, we're trained in certainty. And when the answer is not certain, it's confusing as hell and we can't participate. We need to develop the ability to separate clarity from certainty. So we don't know for certain what the business model will look like. We can learn from our software friends that business models do emerge that are actually quite lucrative. Red Hat is not a poor business, right, by any stretch of the imagination. That doesn't mean everybody will turn into Red Hat, but we know that business models emerge around supporting open source artifacts. and commercializing open source artifacts. And commercialization is absolutely, commercial support is absolutely fundamentally required to make open source hardware implementations viable. No question, right? Without it, we will have, smallish, very enthusiastic, mind you, but smallish, hobbyist kind of projects that will not achieve critical mass needed for adoption in the industry. So don't be afraid of the uncertain aspects of where this might go. Embrace the clarity that there will be a solution, even if it's not immediately obvious.
By the way, do you think that the fact that the EU put $1 billion in the direction helps, or maybe create some expectations that will have a negative effect?
I think the reality of it is economic stimulus is required in order to make this kind of a movement successful, and a combination of federally or government-sponsored economic stimulus or commercial-sponsored economic stimulus, industry-sponsored, is required. So I think it helps. I know that there's often some trepidation from the true everything must be free and open and accessible, sort of dyed-in-the-wool open enthusiast, that all problems must be solved in order for it to be truly open and transparent. I used this analogy earlier. You cannot eat an elephant in one bite. If you do, it will be very painful. So try to just chop it up into smaller, manageable chunks. Let's solve a few of them while we can. The advent of an open ISA is a good start. So we've got RISC-V as an open ISA, that's a good start. We can probably convince ourselves that there's some half-decent open cores around, that if we validate them and verify them properly and share them, we can use those too. And then we can gradually maybe move to simulation tools and other elements that surround the whole ecosystem. But let's not try to swallow the elephant in one bite. It's very, very uncomfortable.
Okay, you might be wondering why I'm sitting here. I like to talk, so today I didn't get to talk, so this is why I'm sitting in the panel. So I'm from the academia. I've been doing this I've been doing IC design in academia for more than 20 years. And it's actually very interesting. You might have been maybe on the receiving end of my pleas for the first, let's say, 15 years. For making projects, we've been begging companies, IP providers or others to do something together so that we can do also interesting research. It wasn't happening. Ever since we started doing open source hardware, actually, we had much better projects with the industry than we had when we were still the same capabilities, same people doing the same type of things. But right now, for the industry, we are more interesting to work with. I mean, the thing that we did with Dolphin and Mr. Wolf is a very good example. I mean, we were looking for those IPs for many years. We were begging, we were even prepared to pay money. We tried different things, it didn't work out. Once it's open source hardware, they realized, hey, they're not, I mean, we can give them our IP, they'll use it, they'll make a chip, we can have the rest of it as we see fit, and that was good for us. So for us, it works actually surprisingly well. Of course, I'm not on the industry side, so it's not for me to say what works, but as an academic institution, we saw actually much better relations with industry, much easier collaboration models with the industry. The lawyers weren't very happy. They're saying, what do you mean there's no foreground? What do you mean the background will not have to be negotiated? Say it's open source, I don't need to. Yeah, that's it.
Yeah, you pretty much addressed most of the things. Maybe just a little addition to this. I have been on both sides, so it's academia and industry, and it's an interesting time, as you, Rick, mentioned. It really is, because the changes that are not you know, unusual are not really changes. This is just like another version of a earlier product. So I truly believe that it could be a true change in a processor ecosphere. But I kind of also have some engineer in me saying that it's not always, smoothly. So I still see as a potential issues that we have to work on is, we are aware that it has been number of, lawsuits, especially in the hardware domain, claiming that, yeah, we did that, first, and, this is something that we did, and you didn't do that. So, I mean, we do have a lot of, I would say, legal battles, here to fight, where there is no really only engineers on both sides, but there are a lot of how you actually phrased something earlier, and it's going to be also challenging, apart from just pure technical work that we have to do.
I like that you mentioned the legal side, but because engineering is one side, it's usually easier. And then the lawyers come in, patents come in, and then what the hell? I mean, I created something that I thought is okay, but then some lawyer from some other company comes, and it's not easy. I think it's harder than the engineering part.
It is even worse because usually companies are holding patents in order to fight against a lawsuit against them. So when somebody sue you, so you have many patents that you can actually claim that it took from you. So we swap patents. When you work in open source, or when this is the way the patents are used. But universities or open source organization don't have this pool of patents because you cannot have patents if you are open source. So you don't have anything to negotiate with.
Well, I would like to add a disclaimer there that many of the open source licenses do have patent grant disclaimers.
Open source
Yes.
organizations.
Licenses.
Oh, license, yes, but if you are an open source organization,
So you're both right, but you're talking about two different things. You're talking about a patent portfolio as a defense mechanism against a countersuit. Part of the way to address that, and so for those of you that weren't here earlier, I started the RISC-V Foundation, and one of the elements of the membership agreement that was hard to get in there, but nonetheless, everybody signs the same agreement. With my hat, I signed off 235 membership agreements, and they're all the same. And there's a covenant not to sue paragraph in there. There's some sort of get out of jail free clauses around it, but fundamentally, there's a no suit or proceedings paragraph inside the RISC-V membership agreement. And it effectively pools the entire industry's patent portfolio. It doesn't mean that we're all going to come to each other's defense, so we'll take two large members like NXP and Qualcomm with large patent portfolios. Just because one got sued doesn't mean the other one's going to go and defend them in that suit. But the stronger participation around that membership agreement, you get this sort of safety of many kind of community that everybody is party to the same covenant not to sue paragraph. It makes it interesting. It doesn't necessarily stop trolls from coming along when that's their only business and that's what they'd like to do, is just sue the whole damn industry. But it's the best you can do because you can't really stop anybody from, whether they have a frivolous claim or not, you can't stop somebody from launching a suit.
Rick, just listening to that, which was very good, it almost sounded like you were arguing the case for an open invention network for the hardware space in the same way OIN does that for the Linux space. Is that what you're arguing the case for?
Well, I'm not as familiar with it for the Linux case, so I don't know that.
It's a consortium of,
Yep.
It's got most of the big companies in now,
Yep.
where they all agree that they won't use patents over
Yeah.
the Linux
Play nice in the
coexist against
sandbox.
each
Yeah.
other.
Basically, play nice in the sandbox kind of rules.
Yeah.
Yeah. And that's similar to the mechanism that's in the covenant not to sue section that's in the RIS5 membership agreement. And I think it's important when we talk about open source licensing that whether it's in the license or in the permission description of the actual IP, that we have that kind of a provision together with the open source artifacts. So figuring out how to do that, whether that's in Solderpad or whether that's in some of the other licenses that we're talking about, I think is an important consideration. And well, I'm sorry, I was going to offer an opinion on how some of these guys behave, but I won't do that.
I'm wondering if the open hardware community also brings in some way some fresh air and some new innovation, especially into the side of tools, because I mean, especially if I look into the hardware description languages, and there is a lot happening on this side. I would like to know what your take is on that.
So were you talking specifically about the organization I was mentioning, or just in general? Okay. So let someone answer.
Innovation in tools, maybe the academia, for example, has been not active in this thing because we've been pacified by, let's say, EDA companies giving us licenses for very, very favorable things. So for many years, people said, okay, you know, synthesis problem has been solved. There's not much to write about it. And you get access to basically top-of-the-line tools, be it from Cadence, Mentor, Synopsys, or the other companies I forgot to mention. And that made us lazy. I mean, we have to face it. The academia in general. And maybe we should have done more, and for the enthusiasts, it's a very difficult market. I mean, you can work on software on your own. That's very possible, but ASIC design tools require you to be part of an ASIC design cycle and chain, and not everybody is in this business. It's a very small and specialized place. You find more simulation tools. This is not a coincidence that you find a lot of simulation tools right now that are excellent for in the open source domain. But it will take some time until you have some DRC tool or some LVS tool that matches. It doesn't have to beat anyone. It has to be, let's say, in the ballpark of it. But it will probably happen. I mean, we see a lot in the tool space also. And I agree. I mean, we are far back in the tools than we are in, let's say, designing architectures and making hardware available.
There is a
Before we change the topic, I have hit him in the head. Before we change the topic on, because I think it's a really valid point around the tools. There are many barriers to entry for a truly transparent and open source hardware flow. Tools is one of them. Obviously, the recipe for the geometry and the node, the PDK, if you will, some would argue that it's not a mystery at all, but clearly the foundries hold all that stuff really close to their heart. And I go back to the elephant analogy. Trying to tackle all of those things at the same time is quite challenging. Trying to bring the semiconductor industry out of the mothballs by showing them that there are viable commercial models for them to be able to use and rely on open source artifacts in our ecosystem. Be you a verification tool vendor, an IP vendor, an SoC vendor, and so on. Making some progress with some of the things that are right in front of us, I think, is a good approach to eventually getting there. Because I agree with Frank. There are activities, and we will get there. But let's chop the elephant up a little bit.
So just to give some personal experience about IDEA tools and innovation and open source things. So basically, there is it's like a snake which is eating its own tail, because if you go to the academia people and you show them some innovative way of doing things, they will say, oh yeah, but we have to train students for the industry. And when you look to the industry to give them some new things, they will tell you, but nobody can use your tool because the people are trained to the legacy way of doing things, VHDL and Verilog. So it's really a hard situation to get out, because not many people want to take any risk with the tooling. People are really comfortable with the actual one, even if I should say, personally, I worked 1 year in the industry doing GPU design, and that was hellish. That was using VHDL, doing monkey coding the whole day. I mean, if you look at software tools today, they really evolved with time. But the IDEA world, I mean, I don't have probably the worst picture, but it's like a stone age, and it has to change, and maybe it has to change from the academia, because there they can take more risks. But yeah, there is this snake eating its own tail. Like there is things like Scheisel, maybe you hear about it. FHDL, Megan, Lytix, which are trying to innovate into the RTL entry. Spine HDL, there is also Clash. There is open source initiative to bring new hardware description language to the table.
I totally agree that we need to work on the language side. And from my point of view, I think we will need to see more domain-specific languages in the future. We will need, I'm fine with doing control logic in Verilog, but I would like to have a graphical top-level tool. I would like to have a HLS tool for describing my algorithm of sort. I would like to have some kind of special tool for doing DSP or for doing audio work or for whatever I want to do. But the thing is that they need to work together, and currently they all need to compile down to Verilog because that is the entry point to all the EDA tools. So I have been talking to some EDA tools about opening up the front end a bit because I mean the EDA tool vendors are not selling Verilog parsers or VHDL parsers. They are selling the tool. So the only company that will actually lose business on this is the company that provides the parsers. And this would allow different tools and different projects to collaborate in a much better way. As an analogy, we have in the browser space, we have had JavaScript for a long time. Then people built languages on top of JavaScript, like CoffeeScript and TypeScript, but they all compiled down to JavaScript. And then eventually everyone settled on this WebAssembly thing. I think that's the thing we need on the Silicon side as well, intermediate representation language. And there are efforts going on here, but I would like to see more, and I would like to see more collaboration around this.
Whether this is a good thing or a bad thing, it is fact. The people that ship millions of SOCs a week have a tool flow that is based on a verification environment that is Verilog, System Verilog, UVM based. The tens of millions of dollars that they spend on deep submicron mask sets and committing a device to production, the flow that produces known good silicon is sanctity. You mess with that, you'll lose your job. So unfortunate as it may be, as archaic as it may be, that's fact. We can change that. It'll take time. On the front end, where we can influence the open source mindset into that community is where some of the good work that's been done here around the cores and so on, we can actually start to influence that open source mindset more easily. The analogy I used during my talk about betting your badge on the RTL that you download from some repo, we can cross that chasm. The rest of the known good silicon at the other end of the verification flow is a very, very challenging thing to go and break right now. And it will be, I think, for a little while longer with the guys who ship high volume. And we want those guys at the table because that's where a lot of the commercial funding will come from. That's my view of the world.
For companies to change tools, you need a very, very good reason. Even if you show them that you can improve it 10, 20% something, most of the time manager will not take the risk because the risk that if you will not get to the point, or if something would happen, the manager will lose his job. So you need one of the two. Either you can prove that this can destroy your opponent, or that it will give you something 2x or order of magnitude for something to happen. On the other hand, this is going to another question that I have. Most of the changes happen from bottom up, from some niche market, and then they were expanded. And all these disruptive technologies usually started with something that has a benefit for very narrow applications, a number of applications, but it has a major benefit for these applications. Now, in our terminology, is usually the difference between a general purpose and a special purpose computing. And my question is that maybe the strategy should be to start with embedded system or domain-specific application, gain the confidence that we are doing something right with the tools, with the module, with the business, and only then try to go to high performance and to compete with the big companies. Anybody wants to comment?
Yeah, there's the definitely easiest option. Start with something simple, like Rick mentions, not hunting the elephant in the first place, and try to figure out something smaller that you can prove that you're right and it works, and you got some improvements here and there, and then it's going to expand either with some help or not. So you shouldn't try to kill like everything in one go.
You are all talking about these people building million of stocks a minute or whatever it is, very high volume stuff, and very large companies. But we are also missing the fact that we could enable a lot of startups who can afford a few tape outs, and if that succeeds, they can keep working. And these are, for them, the tool costs are a much higher cost. And I know of chips that have been taped out almost exclusively using Verilator for verification. So, I mean, this happens. And we had a very good presentation by a guy from Microsoft Research at OrConf a couple of years ago, who had been looking at the landscape of startups for silicon compared to software. And it was so few startups compared to the number of companies in the silicon space, because no one could afford starting up. And this is what we need to enable. We need to get more software developers into this, and we need to make it easier for startups, because we are way too few right now, and we need to find ways to enable more people.
So I completely agree with the point about ASIC production, and you're not going to move that quickly. But at the end of Moore's law, software-defined hardware, domain-specific languages are very important. And the best way to prototype those is FPGAs. And by coincidence, if you are China, who has a strategic supply chain problem in America, or if you're America, who has a strategic supply chain problem with China, or if you're Europe, who has the same thing, you have to start small, right? One byte at a time. And you start with an FPGA that checks the other hardware. You take a small FPGA, you put it in your system, and you code and that's trustable. But guess what? You need to evolve that code very quickly. So you need an open source tool chain for the FPGA, for security, for sovereignty, for strategic purposes. And there's a lot of people working on that right now. and in fact, we believe that if you're in a adversarial situation in your supply chain and in your software, you actually need AI to iterate the tool chain against different threat models. And you can only do that if the whole tool chain is open. So there's essentially a new class of EDA tools needed for root of trust. And so the Quattro initiative that was talked about earlier today, DARPA has a program, several programs in this area. So I think there's a whole class of new tools because of the end of Moore's law. So what we really need is we need a consistent FPGA dev board that the industry can rally around and build tool chains for. The Net FPGA program has done that over 10 years, but that's still several $1,000s. So if, yeah, that's the pitch.
But if you're doing something that has a huge market, and suppose that you are a small company or startup, the big companies has many more employees, they have more means, they can do it much better than you. So it is not enough that you will start with a FPGA or simulation, whatsoever. You need to find the right niche that will not compete as a startup or as a small company. It will not directly compete with the big companies, because otherwise you're lost. Yeah, but it doesn't matter. I'm just saying that the strategy of FPGA is correct, because as a small company, maybe you don't have enough money to make an ASIC out of it. But again, if you try to solve something big, it's not just the size of the design. If you try to compete with something which is the bread and butter of the big companies, I don't believe that you can. I think that you need to find things which are not really threatening or addressing main businesses of the big companies, and only then you can succeed and to be either expand or bought by the big companies.
Let me be a little bit controversial here. I don't think the EDA tools is a big deal. The EDA tool companies have it very, very difficult. Assume you are a startup, you have a brilliant idea, and your idea will sell 100 million chips. You don't care about the money that you pay for licensing for the EDA tools. It's not something that will bite into you as much. See, the EDA companies have it very, very difficult. They sell you a license, and they cannot take part of the profits you're making. They can just, whatever they manage to get out of you while you're, being funded, what they negotiate with you is the price they get. If you are a very successful startup and you make 80 million, they're still getting the same money. Or if you are a startup that goes under and doesn't sell a chip, they still take whatever they did. So I don't think the EDA company thing is stopping the things. It's actually a hard business. It's not an easy thing. If you have volume, if you can sell it, you can also manage to find the money to pay for the EDA tools. Regardless, you could make the argument, why aren't people making open source or closed source? Why are there only 3 companies that are making EDA tools? Well, the companies that come up are more or less coming up so that they are being swallowed by them, that's first. And second, there's not really a good business out of it. You cannot really hope to make a lot of money by making a DRC tool, let's put it that way. But would it be very hard? These people here in the room, if we just lock us up, I think in a week we would have a decent DRC tool that maybe not make it for whatever 7 nanometer, but I'm pretty sure we can get a DRC tool running in a week with these people here that does fine for 180, 90, whatever.
Did you guys all hear the doors lock? We're done, man. That's it.
But you know, why would we do it? What do we get out of it? There's no value proposition in it. I worked on asynchronous circuits for many years during my PhD, and the main point is, and Steve Ferber says it very famously, the value proposition of doing it that way wasn't high enough. Avi was saying the same thing. I mean, if you do something 2x better, 3x better, then you have it. But if you're doing it 10% better, the cost of switching, changing ideas, bringing new things, compared to the risk of failing while doing so is too high, so nobody wants to do it.
Okay, so some patent lawyer who claimed to be familiar with RISC machines and also MIPS patents said that at a certain point, ARM or some other companies will use these patents to fight against RISC-V. Do you have any comments, concerns, or suggestions? Okay, yeah, this is one way. I heard this guy said that there are some, or as he says, many things are very significant.
So not sure if you're familiar with the genealogy report or research that Dave did with some of his PhD students, where every single instruction that was put into the base spec is traced for its origins, whether it's expired patents, prior art, and what have you. And having said that, there's still no guarantee that someone won't come along and say this infringes, right? Whether it's a frivolous infringement or not, doesn't matter. There's nothing that stops someone who is insistent that they want to, proceed with a suit. They can do so. The best that we could do was what we have in the membership agreement, as you know, right? At the time, when I say we, I meant my past we, to have a no suit or proceedings paragraph, right? So as a minimum, the 200 and now over 50 signatures that are from industry that are on that membership agreement creates safety in numbers. But there's nothing to say that RISC-V or otherwise, if someone is convinced that someone's infringing their IP, they'll try to do something about it. Yeah, MIPS opened their ISA.
Right. So since MIPS folks have positioned themselves against RISC-V in openness, it would look really bad for them to start suing people. So I don't think that would be.
MIPS did not position against RISC-V or ARM or anybody else for that matter in openness. They just decided to open their ISA. I'm not sure what you mean about the position against part. It's not exclusive or, right? This is the whole thing is not an exclusive or. The death of Moore's law means, by definition, we're going to have multiple cores doing specific things to, domain-specific cores to process that data. We're going to have heterogeneous clusters, by definition, to solve these problems. Guess what? There's a lot of real good ISAs out there. ARM's one of them. My goodness, look at all the devices that we have in the room around here. There's lots of ARM stuff in there. Hallelujah, pass the hot sauce for ARM, right? So it's not exclusive or. These things will all coexist, and for some time, including MIPS, right? It's not going to go away. So, I used to get that question all the time when I was running the foundation. Oh, okay, so I guess this is the ARM killer. I go, hell no, if it is, then we're all in big trouble, right? Because, that's very good technology that has benefited the industry significantly and will continue to do so.
Can you comment about the claim that US can at some point put this export license issue and prevent Europe from continue to develop RISC-V based
Yeah, sure. Well, I'm not a lawyer, but I play one on TV. Okay, that's not true either. I have had that question so many times. I mean, okay, you cannot rationalize irrational behavior. So that's the first comment that I'll make. The other comment I'll make is the bullet has left the barrel, right? It's really hard to catch it and stuff it back in again. So I'm not sure what it would look like to try to turn off the specifications associated with the RISC-V ISA, because the foundation's responsible for the ISA specifications, as you know, no implementation. Right, ITAR and those export controls are related generically to, tangible IP and implementations. And the ISA spec is not an implementation. That doesn't mean that they couldn't try to wreak havoc. But how do you pull back a series of specifications that is already populated throughout the world?
No, you cannot do it, but you can, for example, prevent to use it for military purposes or for
Sure.
or airplanes.
Yep.
Or
So now we're going. Yeah.
settlements.
So now you're asking me to rationalize irrational behavior. So what some large political body might try to do to influence other political bodies is it's way above my pay grade. I can't comment on that. And that's independent of what you have in a license or not. I mean, ARM is clearly a U.S. company, right? So we'll tell ARM that they can't do business with a company in China because they're clearly a U.S. company.
ARM is not a U.S. company.
I'm being facetious and sarcastic, but that's exactly what's happened. So.
I think the open hardware community can take some comfort from people who've tried that game in the software community over the last 20 years. Look at Oracle acquiring Sun and trying to take OpenOffice private. It immediately forked into LibreOffice, and they effectively killed the #1 product in the world in a few weeks. So once something's open, no government in the world, no matter how powerful they think they are and how irrational they may be, really struggles to kill stuff like that. And I think open source software gives you some comfort in that when it's happened to software.
I want to shift gear about something else, about the business model of open source hardware. We are hearing from VCs and other people that they still don't like to, or at least many of them don't like to invest in open source hardware. What we can do, or what do you think that should be done so that VCs and private people will invest money in this area?
Well, I think personally, I think an objective should be to get at least some moderately complex IP block shipping in large volumes, high volume SoCs, and just, if nothing else, as an existence proof. I go back to the clarity versus certainty. As open OSs started to emerge, I don't think too many folks could have envisioned models like Red Hat. As an example, don't get me wrong, I love Red Hat, but I'm not like a huge cheerleader or something. It's just, we can point to that as in hindsight, as something that seems kind of obvious now, doesn't it? There will be similar models that emerge that might seem kind of obvious. There are some VCs that are interested, maybe not the ones that everybody knows off the top of their head, but there's enough activity and enough interest and enough pull by some of these large semi guys to give this a go that, where there's smoke, there's fire, and that hopefully isn't the chip on fire, but.
He's filming me, right? Okay. I mean, you had also a similar thing when we moved to digital photography or things. There were a lot of shops that weren't probably very thrilled about the fact that you didn't need those shops to print your pictures and everybody could make tons of things. And if you're from the Rochester area, you might think that it was a very, very bad idea. But you see how things evolve. You know, there are now photo shops that tell you how to take digital pictures. They train you. They make different things. So there's also a lot of business around, and there is also business around open source software. It's not like because there's GCC, nobody's making money out of software companies. It's the same way that once there will be more open source hardware that's accepted and used in SoCs, that there won't be proprietary hardware. It won't be that hardware designers will only do things for free. There will be, as they mentioned, different ideas and businesses evolving around them. I mean, there was a discussion from Codese, for example, is an excellent example. There's so much that goes into making the chip, making sure it works, and a lot of it is service. It's not that you get a license for tool X, core Y, and immediately a startup has a chip running and selling in volume, just ramping up production and all these things. They are all services around there and they will remain. And they will coexist maybe, or they will embrace open source because they may see it for their part as an opportunity.
Yeah, maybe just to add to this, when we consider the open source software community, I mean, okay, you get something for free, but not the whole thing is free. I mean, you pay for a lot of the services on top of that because, okay, you want to use some open software, but then you need some guys to maintain it. You need to add some features that are unique to you or to your organization. And for that, either you collect your own team for which you pay or you pay some outside services. So this is the same thing that I think it's if we manage to get this along the way, it's going to happen here. So yes, okay, the core or the basic hardware is going to be free, but as you said, you're going to have to embed it together with other modules to create your own version of whatever it is, not to copy off the shelf thing. And there's going to be a lot of activity, business activity around there. And this is where I see the VCs will be interested into investing in this business aspect and business model. So, they always mention, when also with the free software, I mean, it is kind of free, but it's not really free. There are costs associated with everything today. So it's going to be like that, but you're not going to pay for just, one small chip there or the architecture or something. You're going to pay for the things around it, but you're not going to license the actual, architecture or the hardware under. So I think it's a kind of, it is a viable and sustainable model.
So I think it's important to make a distinction here. There are companies that do very high quality IP, processor providers and other providers. There are companies that do very high quality EDA tools. They will always continue to exist. There will always be a need for them. But I will show no mercy to the low and crappy stuff that people try to sell. And those will go away. And that will be the change in this business, that we will see SPI controllers, they will always be open source because no one should pay for a thing like that.
On the business model comment, I think sometimes we forget that you can charge for things around hardware. And so, Red Hat gets bought for $34 billion to compete with the cloud. But Amazon makes a ton of money on open things. And now Amazon has FPGAs. What are you going to run on that FPGA? You're going to use open cores, probably. especially if you're uploading it to Amazon. You're not going to send super secret IP to Amazon. So, so Amazon is going to win, is going to make lots of money renting you FPGA hardware to run open things. Maybe they'll support tool chains. Who knows? They have a lot of money. And the other thing is augmented reality is coming. So augmented reality is latency sensitive because the human brain can pick up very small differences. So that's a huge market for small, low power, latency accurate chips. These are all new ways to make money.
Wait until someone tried to throw it right up the top. I was just going to, there was a little muddle going on there to distinguish that when people talk about free software, the type of free we're talking about is freedom, not you don't pay money for it, because free software is often very expensive. And I think you can look very usefully at, say, the business model of AdaCore. You can go and download AdaCore's software for free. GNAT, the GNU Ada compiler, all contributed upstream. Thing is, if you want to build an aircraft with it, you want it certified. And Ada's test suite for that NAT is not free. So if you want a certified compiler, so I think there's a good model there for hardware. Yeah, the hardware's free. You want to be sure it's right. That verification is not free. And of course, verification IP companies have always been valued higher than actual IP companies.
So we've heard some good analogies against the great success of open source software, right? Linux being a perfect example. But when Linux first came out 20-something years ago, it was not very good. And it took years of work by lots of smart people to make it good. And they put their time in, and it was fun to play with, but it was actually useful before it was perfect. Now, hardware doesn't work on imperfect, right, because of the cost of the tape outs and so on. How do we build a community around an open hardware artifact if it's not useful until it's finished?
I mean, I stand by my comment. I mean, there is a lot of value in things that are not perfect. And I don't mean that they are buggy, they will not work. It's just, for example, they are not as fast, as powerful as something, but they still work because not everybody is in the market for top-of-the-line things, be it simulation speed, be it operation speed, whatever. So I think the same happened with Linux. If you wanted to, I mean, I was alive then. We were in Turkey. I'm from Turkey, and we needed network infrastructure. And then you realize that you can take a 386SX, and you could make a bridge and router out of it. You could make your mail server out of those things. And it worked very well, and the competing product was very, very expensive. I took out from the trash computers, turned them into routers, bridges, and that said, hey, this works. Does it compare with a Cisco router? No. Does it have to? No, because I'm a small operation, I could live with it. And a big company wouldn't stake its entire backbone to those things. But it caused a lot of people to stop and say, hey, this is a viable idea, this works. We can put some effort into it and it will work even better. And now here we are today. And I would say we are like, again, in those days of open source software, we are right now at open source hardware. And a couple of people realized, hey, we could make this work. And we were very surprised and very proud as ETH Zurich to see that some companies actually made products out of the things we made. They probably didn't choose it because we were beating out all the competition and that was the best core ever designed. But it was good enough. And that created some people to take notice and say, hey, that's good enough, we can make really good. And there is some incentives for doing it. And I think it will grow like this, hopefully.
Fundamentally, to add a little color to Frank's story, people looked at the cores, the risky core, the Ariane core, for that matter, the zero risky, now IBEX with low risk. They go, hey, you know what? And these are people who have designed cores for a living to produce the high volume SoCs, as you know, right? Look at this stuff and go, hey, these are pretty good. PPA analysis looks good. These are actually as good as we could have done, but maybe a little better. They'd be proud and convince themselves that they'd do a better job, of course, but good enough. So are we at a tipping point where, okay, if I now prop this up and I convince myself that we've got the right code coverage, we've got all the right verification tool flow in place, I can stitch it into my design flow easily, then do we have that design engineer who's going to bet their badge on an RTL block that they downloaded off some guy's repo, right? And we're getting to the point where that's more than good enough.
Just add another sentence. As there is current risky maintainer until it's going to be open hardware. I can tell you that every time I dealt with companies, the very first things that they saw is the license. The very first thing. They didn't say, this is faster than what we are using. This is smaller than what we are using. The very first thing is that this is for free, open, well-written with a permissive license. They never mention speed. They never mention area. That came way later, but if it came out at all.
Thank you for a very great panel. I'm actually an outsider here. I'm a software entrepreneur. And the reason I'm looking at this stuff is that more and more software and hardware integration can produce some values in some niche markets. And I went to a presentation by Google when they were using the Chisel EDA, open source EDA tools, and they used that to create their inference chip that is going to all the Android. And that was a very eye-opening presentation for me because they had a big team working on it, and they ended up hiring a lot of basically the Berkeley team that did the Chisel to help them ship that chip. And what they said at the end when they evaluated their project, they said that their engineers, they said basically using Chisel was great. We like open source. But it made the long tail of chip development even longer because the verification became the problem for them. And I think in the open source software, that was another tipping point, which was when they had the DevOps and the verification that you could use as a startup to rely on the reliability of the open source packages that you were using. So I think I'm looking at it as a startup. I've been to see if I can take advantage of this. And if there was some verification, some identification, some indication of what is the risk we will be taking with the open source versus commercial, and some level of same functionality that the DevOps brought to open source software, that's to say, if you use this package, this is what you will be getting and what you can expect. That, I think, can go a long way for those niche applications. And once those niche applications become reliable enough, then it can expand to the higher level market. And I, as a software startup person, I would love to know when I can rely on these things. And that, I think that I just wanted to add that comment as an outsider, and thank you for indulging me.
I want to extend your point and question about security, not just verification. From security point of view, open source that you are getting the model from very different vendors, if you like, or developers and so on, is more secure than getting something for company that you trust that work with commercial tools, etc. Or what is your opinion?
So yeah, so clearly open source or not open source, in both cases you can request the source code and do some analysis. In my point of view and from my experience, the open source was a way to, when building disruptive products, it's easier to start with open source because you do it at your pace. You don't have to, for closed source products, the first delivery you get is completely the compiled thing, so the black box. And if you want to look into it, so for doing your due diligence regarding security, of course you need to pay for more than that. And so as a bootstrap, it's really good to set the level of what you can expect, and two options. You can live with that, or then you can challenge other companies. But the huge benefit I see is that you have a fair way to analyze the offer, the commercial offer, because otherwise, it's a market where you need to trust what the vendors will tell you. Now with open source, you can make your own decision. And this is very valuable, and globally for the industry, it has a strong impact to push the standards higher. This is my.
Do we have the tools to do it? In theory, you're right, but the question is, we have the tools to do the verification of the functionality or the security in such environments.
That's orthogonal questions to how to check for the security. So
this was the question about the verification.
So when it comes to this last question, I would like to say something about formal verification. When I was in university, we used formal verification, and when I came out in the industry, it turned out that no one was using formal verification. So I didn't do any formal verification for 10 years until very recently, when there became available an open source tool for doing formal verification. So this is an enabler. If this tool had come 10 years earlier, I could have had 10 years of experience in formal verification because I had access to the tools. And that would be a big win for the companies that actually needed to use formal verification. So once again, we need to have more freely available tools to enable more people coming in, because at the end of the day, the problem is that there's too few engineers actually able to work on these things. And that's again with the Chisel, as you said. I know the Chisel people very well, and many of them have a pure software background. They have no experience in hardware, and they can still make large parts of the chip. And again, the verification part, I agree with that it makes things more complicated. This is why I want to push for this IR thing, because we can't go through Verilog. We lose too much context, but we need to push for a better IR.
Completely agree. I think it would go a long way, even if it's using commercial tools. Say, this part of the process is open, you can use this. And for using this whole design, these are the commercial tools that you can use. And this is how you would use them to have an end-to-end solution. And then you can, as you were mentioning, bite off different pieces of that whole workflow. But it would go a long way if you have a verifiable process end to end, even on an FPGA, because those niche projects at the beginning can use an FPGA. You don't need an ASIC for those things. Like Microsoft in Azure, they're using FPGAs to do network. Their networking stack a lot more efficient. But I mean, that needs to be done.
By the way, companies like Intel do a formal verification on their chips. It doesn't prevent bugs, but yes, they are doing a formal verification on major parts of the chips. Intel are doing formal verification on major parts of the complex parts of the chips. Yeah, so. More questions? Okay, from outside here? Okay. Okay, so thank you very much. And I hope that you enjoy it.